Welcome to physics class. And today we are looking at motion under gravity. Now, motion under gravity is a type of motion that is influenced by what is called gravity. It's a type of motion that is influenced by gravity. Gravity is a force that exists in nature. So anything that goes up always comes down because of the force of gravity. Now, this motion can either go down, right, vertically down, or vertically up. So, this motion is known as a vertical motion. Vertical. So, it's a vertical motion. Another point about this motion under gravity, it is influenced by an acceleration. And this acceleration is known as acceleration due to gravity. Acceleration due to gravity. Now, while horizontal motions are affected by normal acceleration, horizontal acceleration, vertical motions are affected by acceleration due to gravity. Is that okay? And then this acceleration due to gravity, it has a value represented by g, and the value is 9.8 meters per second square. Don't forget the unit of acceleration is meters per second square. Now, this value is usually approximated during calculation. Most times it is given as g equals 10 meters per second square. So any of the value that is given during calculation will be used for the calculations, right? Now, before we start doing some calculations for motion under gravity, we need to know some rules for the calculation, and we also need to know the necessary formulas, okay? Formulas that will be used for the calculation, okay? All right, some of the points that we need to note before we start solving are, number one, if the motion is downwards, g, which is acceleration due to gravity, will be positive, okay? Number two, if the motion is upwards, g will be negative. When you are going against gravity, g will be negative. When you are going in the direction of gravity, number one, g will be positive. That's what we mean, okay? Number three, if a body is simply dropped from a height, if you drop any body from the height, when we say body here, we mean object, all right, ball, can be anything that is dropped from a height, the initial velocity used to be 0. So if you release a stone from a height downwards, at that height where you release the stone, the initial velocity u will always be 0. Number four, when a body is projected vertically upwards, the final velocity v at maximum height will be 0. So if you throw something up, the point where it reaches before it starts coming down, that point where it stopped before it starts falling down back again, at that point, v, the final velocity, is always 0. So when we are calculating, we're going to be using these rules to do the calculations. That's why we are learning them. Number five, finally, if a body falls to the ground once again, the height above the ground is 0. So S or H will be 0. All right, the height above the ground will be 0. So take note of that. All right, next we are going to be looking at the formulas that will be necessary for the calculations. So on the left hand side, we have the horizontal motion formulas. On the right hand side, we have the vertical motion formulas. All right, the formulas are similar because they're almost the same, but just little adjustments. Now, for the horizontal motion, v equals to u plus 80, that's the first one. All right, x equals to ut plus half at square, v square equals to u square plus 2as. Okay, now the one we're going to be using for the vertical motion calculation will be the one on the right hand side. So v equals to u plus or minus gt. Plus or minus indicates either the body is going up or the body is coming down. If the body is coming down, we said we're going to be using plus for g. Okay, if it's going up against gravity, we'll be using u. So that's why you have plus or minus. We're not going to use both signs to solve. We're going to only use one of the sign, that plus or minus. The formulas are the same. Small adjustment, a here. Anyway, we'll see a in the formula on the left hand side, we'll replace it with g because it's vertical motion now. So g, and then g. Then we'll also replace s with h. So those are the difference that we have in both formulas. We're going to be using the right hand side formulas to do our calculations. All right, we have the first example. So example 1, a body is released from a height of 30 meters. Calculate the time it takes to fall. That's the A part of the question. And the velocity with which it hits the ground. We're given g as 10 meters per second square. Okay, it's going to be square for its acceleration. So we have our solution. We need to bring out the parameters first. All right, it's released from a height, so the height h is given to us as 30 meters. Okay, and then we know that g is a constant that is also given to us as 10 meters per second square. Okay, and then u, since the body is dropped from a height, we said when the body is dropped from a height, the initial velocity u will always be 0 at that height. Okay, meters per second. Okay, that's all. And then we're looking for the first part, calculate the time t. And then the second part, we are looking for the final velocity v. So these are the two things we are going to be looking for. All right, so let's look at the first part of the question. So for the first part, we're going to look for the formula that we just finished discussing, the right hand side, formula that have h, g, u, and t. You check very well. That formula should be I think the second formula should go for our calculation. So h equals to ut plus half gt square. Okay, we are using plus because the body is released from a height. It's released from a height. All right, I'm going to substitute my values. I have h as 30. Okay, I have u as 0 times t. Okay, and I have half times 10 and then times t square. Is that okay? So I have my 30 equals 0 times t will give us 0 plus. Now half times 10 will give us 5. So 5t square. Okay? So what I'll do next, now as it is like this, we know that 0 plus anything will still be that value. So I'm going to have 5t square equals to 30. That's what we're going to have. So in this case, we're going to divide both sides by 5 in order for us to get t squared. Then we'll find the square root to get t. Okay? So dividing both sides by 5, we have t squared divided by 5. And then we have 30 divided by what? 5. Okay? That will give us t squared equals to 6. Can confirm to check. So t will now be the square root of 6. And square root of 6 will give us 2.45 seconds. So 2.45 seconds. That will be our answer for the time, all right, it takes to fall. All right, for the second part of the question, we already have our time to be 2.45. Now, for us to find the velocity, we are going to be using a formula that have velocity. V equals U plus GT. Okay, we're looking for V. We already know U. G is given to us. T, we just found it in the A part, in the first part of the question. Okay, so we just substitute our values. So V will be equals to 0 plus G, which is 10 times 2.45. Okay, so V is equals to 0 plus 10 times 2.45 will give us 24.5. So to add 0 plus 24.5, we're going to have V as 24.5 meters per second. That's the unit of velocity. So that's our answer, 24.45. All right, we have example 2. A ball is thrown up vertically with a velocity of 40 meters per second. Calculate the maximum height reached, time to reach the maximum height, and then C, time to reach the ground again. So first, let's bring out our parameters. So for this question, we have U. U is 40 meters per second. We have G. G is not given, but we know that G will be in the question. We are going to use G as 10 meters per second square. So even if you are not given G, just know that G is 10, so you use it for the calculation. Okay, and then we have V. Like I said, if we throw a ball up, the velocity at maximum height, okay, at maximum height will be 0. The final velocity at maximum height will be 0 when you throw a ball up. To stop somewhere before coming at that point where it stops, the final velocity is 0. So take note that point. And then in this question, we're looking for the maximum height reach. So H, we're looking for H. We're looking for the time to reach that maximum height. Okay, the time to reach the maximum height. And then we're looking for the time to reach the ground again. So we're looking for another T. Let me call this one T1. So those are the things we're looking for. Okay, now for the first part, the maximum height reached, we're going to use a formula that will have U, G, V, and H. So if you check our formula list, you're going to find out that the best formula we can use to find the A part of the question will be V square equals to U square minus 2GH. Okay, just check. Now we're using minus because the ball is going against the gravity, so G will be minus. So that's why we have minus in our formula. So I'm going to substitute our terms. V is 0, so 0 square is equals to 40 square minus 2 times 10 and then times H. Okay, so we're going to have 0 square is 0. Okay, 0 square is 0. The 40 square is 1600 minus 2 times 10 will give us 20, so 20H. Okay, I move minus 20 across to meet the 0 here. We're going to have 20H equals to 1600. Okay, we divide both sides by 20. H will be equals to 1600 divided by 20. That will give us H as what? H will be what? If you check our calculator, we have 80 meters. That's the maximum height that was reached. So for the B part of the question, for us to find the time to reach the maximum height, we're going to use the formula V equals u minus gt. Don't forget minus because the ball is going up. V is 0. Okay. We have u as 40 minus 10. Okay. And then times t. Okay. G is 10. So minus 10t will cross over. We're going to have 10t equals to 40. Okay. If we divide both sides by 10, we're going to have 40 over 10, which will give us our t to be 4 seconds. So we have t as 4 seconds, time to reach the maximum height. Now for the time to reach the ground again, which is the C part of the question, okay, we're going to use the formula H equals ut minus half gt square. Okay, substitute our values now. Time to reach the ground again. For time to reach the ground again, remember I told you when the body goes up and return back again to the ground, the height h covered will be 0. Okay, so h will be 0 at that point because it's returning back to the ground. Then we'll have u, which is 40 times t, okay, minus half times 10 and then times t square. Okay, so 0 equals 40t minus half into 10 will give us 5t square. So I'll move this minus t square across to the 0. We're going to have 5t square equals to 40t. Okay, if we divide both sides by 5, 5 will be cancelled there. We have t square. Divide the 40t by 5, we're going to have 8t. Okay, 8t. So now if we divide through by t, we're going to have t, one of the t here will remain, it's going to be equals to 8 seconds as our answer. All right, so this will be our answer, time to return to the ground again. So instead of using the formula to solve, we can just multiply this our time to reach the maximum height by 2. Time to go to the maximum height is 4 seconds. Time to return back is 4 seconds. So total will give us 8 seconds, which is the same thing as what we have gotten here. All right. All right. In the third example, which is also the last example, the body is projected horizontally from the top of a cliff 40 meters high with a velocity of 20 meters per second. Calculate the time taken for the body to fall to the ground, the vertical component of the velocity when the body hits the ground, and the distance from the cliff when it strikes the ground. So we are given g as 10 meters per second square. So this is a sketch of the diagram. This is the height, 40 meters, okay? And then initially the motion was horizontal, so it has an horizontal velocity of u sub x. This u sub x is representing the horizontal velocity, okay? Now the vertical velocity, the initial vertical velocity is 0 at the beginning of the motion. Okay, so the body starts and then go down. So at the point where it wants to hit the ground, Vy has a value which we're going to find. Okay, but Vx will be 0 because the motion is now vertical. Okay, so the first part, time taken for the body to fall to the ground. Time taken to fall to the ground. So to get the time with which it falls to the ground, meaning that the motion will be vertical because it's going to fall to the ground, all right, to be a vertical motion at that point. We're going to use the equation. We use the equation h equals u sub y times t plus, since the motion is going down, plus half gt square. Okay, now h, which is our height, is 40. So 40 is equal to u sub y u sub y is 0 initially. Okay, so 0 times t, which will give us 0, plus half times 10, and then times t square. So we have 40 equals 0 times this will give us 0, plus half into 10 will give us 5t square. So if we add, we're going to have 5t square equals to 40. Okay, divide both sides by 5, we're going to have our t square to be equals to 8. Is that okay? 8. So t will now be square root of 8. And the square root of 8, if we use our calculators, it will give us 2.83 seconds, approximately 83 seconds to 2 decimal place. Okay, so that will be our answer for the first part of the question. All right, for the B part, which is the vertical component of the velocity when it hits the ground, we've already gotten our time when it hits the ground as 2.83 seconds. Okay, the horizontal velocity initially is 20, while the initial vertical velocity is 0. Okay, meanwhile the final vertical velocity v sub y will have a value. We're going to find that. Okay, that's what we want to look for now, the vertical component of the velocity when it hits the ground. So if we use the formula v sub y, okay, v sub y equals u sub y, which is our formula that we already know, all right, plus gt, which is the formula we have been using. V equals to u plus gt, that's the formula talking about. We just attach y because this time at that point the motion is vertical but it hits the ground. Okay, that's what we're doing. So just substitute value. U sub y is 0. Okay, g is 10, t is 2.83 seconds. So let's do that quickly. We have 0 plus 10 times 2.83. So v sub y be 0 plus 28.3. So if we add 0 to this, we're going to have v sub y as 28.3 meters per second. That's our answer. All right, for the C part of the question, which is the distance from the cliff when it strikes the ground. Let's just look at this. Let's say we have the height like this, and then the motion started like this before it came down. Okay, so what we are calculating this time is the distance from here to where it hits the ground, the distance from the cliff when it hits the ground. That's usually represented as a range arrow. The distance from the cliff to where it hits the ground, that's what we're looking for. Now for us to get this, we need to use this formula h equals u. Now this u is the u sub x because this time it's horizontal distance we're looking for, times t, okay, and then plus half g t square. Okay, so in this particular case now, since it's horizontal motion, the g will be 0. The g will be 0. And if g is 0, acceleration is 0, everything at this point will also be 0. Okay, so this h will now become arrow. Okay, the u sub x will be our 20, so 20 times the t. Our t here will be our time for the journey, that's 2.83. So 2.83. So multiply 20 times 2.83. That will be our answer for the distance from the cliff when it hits the ground. That will give us 56. Please confirm. 0.6 in meters. Okay, that's our answer. So the distance from the cliff when it hits the ground is 56.6 meters. All right, the next questions will be exercises that will be solved by you. Okay, so take them seriously, take a book and a pen, and then solve them and make some comments about the solving. Okay, all right, we have to solve the following exercises. So question number 1, number 2, number 3, number 4, number 5, and then number 6. So thank you very much for being a part of the class.